derivative of y equals 1 over x from first principle. That means we need to find the differentiation of 1 over x. So 1 over x dy over dx. Y plus delta y, that small change, will be equal to 1 over x plus delta x. Take y to the other side, we get delta y equals 1 over x plus delta x minus y. And y is 1 over x. Delta y equals 1 over x plus delta x minus 1 over x. So we're dealing with a fraction now. So x goes up here, x plus delta x goes there, and then we have a common denominator. Multiply that with that. So we get x minus, open bracket, x plus delta x over x into bracket x plus delta x. If we expand the bracket, that's still delta y. If we expand the bracket, we get x minus delta x over x into bracket x plus delta x, and that's still the y. X cancels x because that's plus x and minus x. And now we need to divide both sides by delta x because that's what we're adding for. We're adding for dy dx. So if I then divide that by delta x, that means I'm timesing this by 1 over delta x. It's the same thing. If you're dividing something by something, you're timesing it by 1 over something because I've just times this by 1 over delta x. That's why it's in the denominator. And delta y over delta x equals, well, because that's minus delta x left, the delta x here, we cancel that one. That just becomes 1. So I'm going to get minus 1, by the way. So I just get minus 1 over x into bracket x plus delta x. So in this case, we then have to do something very important, which is in the limit. So let me just draw this line here so that I can do in the limit. So in the limit, so I have to write it down, when delta x tend to 0, as it gets smaller, delta y over delta x will tend to dy over dx. Now I have the authority to use dy dx. So now we can say dy over dx equals minus 1 over x into bracket x plus 0 because delta x is now tend to 0. And that will be minus 1 over x squared. And that will be dy over dx. That's the derivative of 1 over x. Derivative of 1 over x is minus 1 over x squared. Let's do the same thing using the formula approach, where we know that when f of x equals 1 over x, the f of dash x, which means the y dx, equals limit h. Now h is the x, tend to 0. Then we have f of x plus h. Take away f of x, and if you divide the whole lot by h, so remember that h equals delta x. I could have put delta x here, same thing, and that would be delta x. So now I'm going to use this now to solve the derivative of 1 over x. So f of f dash x will be equal to limit h tend to 0. Now 1 over x plus h. So I've just replaced that x plus h minus 1 over x because that's 1 over x. And then divide the whole lot by h. Now cross multiply because we're dealing with a fraction here. So we say in the limit again, where h tends to 0. So we're going to get minus x plus h, open and close bracket, over x into bracket x plus h, all over h. If we expand the top bracket, we're just going to get h minus h, because that's x. So let's do that. Limit h tend to 0, x minus h, because minus 1 times x is minus 1 times h is minus h, over x into bracket x plus h, because you're dividing by h, that'll be times 1 over h. And so we get limit h tend to 0. Now you can see that that cancels that. I'm left with minus h. H cancels h. I just get 1 left. So I get minus 1 over x into bracket x plus h. So I just get minus 1 over x into bracket x plus h, close bracket. Now, in the limit as h tends to 0, so that will become limit h tends to 0 minus 1 over x into bracket x plus 0, and that will become limit h tends to 0 minus 1 over x squared. So still that's all f dash of x as h tends to 0 will become minus 1 over x squared. And that's the derivative using the book's formula approach from the first principle. So that's the first principle formula you could use. Delta x, because what's going on is basically you've got a graph of, well, 1 over x is basically a graph of that. And you are basically differentiating from a point, another point. You can see it's a curve, and the curves are changing, and the gradients are changing here. That's why you have to use the limit, because you're not integrating between these two. You're integrating between a point here, but you have to make the difference between that and that so small that it will become that point. And then it will become like a tangent that you are integrating on a tangent. So that's what's happening. And that's why you're using in the limit. So the limit is you bring that to distance so small that it becomes a really tiny gradient here. Very tiny, that if you zoom into this gradient here, if you zoom into that, this is what you're going to get. You get that and that and that. And this can be called dy now over dx. But when you're using this, if that was x, that will be x plus delta x, or you might call it x plus h. So that's another way of writing that. So that's just h. So if this is x of h. So now this one will be the in this case that will be the f of x plus h, and this will be the f of x in that case. So that's what's happening. And that's why it's negative, because you can see it's a negative gradient. Because a positive gradient, if you have a gradient, that would be a positive gradient. So that's a positive dy over dx. And this will be a dy over dx, that's a gradient, will be 0. And that will be a negative dy over dx. You can see that's negative, so that's why it's negative. And a vertical gradient, if that's vertical, then dy over dx will be infinity. So that's infinity if it's a vertical line. So that's what's going on here. You can see it's minus 1 over x squared. The minus is because the gradient is negative there. And That's a positive gradient. Zero gradient, horizontal, is 0. The y dx is always 0, horizontal, or stationary if you like to call that. And this is a negative gradient. Negative will be minus.